This one is C5H11O Cl. That would have 0 double bond equivalents. We have a 2H and a 3H over here, and we also have a 6H over here. That would be 2 CH3s. So we're going to have 1 CH2 and 3 CH3s in total. When deciding whether a 6H is going to be 2 CH3s or 3 CH2s, I think what you've got to do is look at the number of peaks involved with the 6H peak. When there's 1, 2 or 3 peaks, because of symmetry requirements, this generally means that we're dealing with 2 CH3s. It's only when we have 4 peaks under a 6H that we think about 3 CH2s. In this case we've got 1 peak, so we're looking at 2 CH3s, and that's why I made that choice. When we look at what's left over, we've got a C, an O, and a Cl. The C is going to be this one here, the O will be this one here, and the Cl will be over here, and you can see everything's counted down to 0, so we probably have the right pieces. Now we've got to decide about where things are going to be attached. Now with regard to the 2 CH3s and under this peak, they have to be related by symmetry because they're under the same peak. That would make me posit that the 2 CH3s were connected to this C that didn't have any hydrogens on it. The other thing we have to be concerned about here is the fact it's a single peak, which means the CH3s must be next to something that doesn't have hydrogens, which means it can't be next to either of these groups, and it certainly can't be next to the O or the Cl, so we're only left with attachment to this C as a possibility. The one thing we can't do here is we can't put the CH3 attached to the same C, because what that would mean is that all 3 of these would be equivalent and the CH3s would all be under 1 peak as a 9H, and that's just not what we're seeing here. We can get a little bit more evidence by looking at the location of the CH2 and the CH3 as well, and you can see that they're both at around 4 ppm. According to the correlation chart, when things are at about 4 ppm, that usually indicates that it's a CH connected to an oxygen. So that would probably indicate that both the CH2 and the CH3 were connected to an O. The one other thing I can tell you is that the CH2 is not adjacent to the CH3 because these are both single peaks. If this were the case where the CH3 was next to the CH3 would appear as 3 peaks because it's next to a CH2, and the CH2 would appear as 4 peaks because it's next to a CH3. That's not the case here. So what that would probably lead me to do is go ahead and put the O here. I'm going to move things around a little bit because, as I said earlier, since these are both at 4.0 ppm, it looks as though both the CH3 and the CH2 are connected to oxygen. And then that leaves us with the Cl, and the Cl can really only end up going here. So that's how I would decide on the structure.